Hello makers. In this video I'm going to look at the stomach badge, I suppose you could call it, on the Inmoov Robot. Now this is actually my second attempt at this component. My first attempt was this one. Now this is a transparent filament. Unless you do solid layers, it does end up being more of a, I suppose you would call it a translucent colour rather than transparent. And on this one, this part has a raised pattern on it, so I tried to pick that pattern out with a permanent marker to get the black marking. These are the parts printed from the Inmoov site, which form this, and you know, for a first attempt it's not too bad. However, as I got better with 3D printing, I came up with this. Now this looks a lot better, and the way this one's done is, again, it's translucent. It's a little bit of a different infill pattern, but more importantly, I actually paused the print as it changed layers to go from the flat disc up to the raised section, and at that point I changed filament from the transparent to the black and then continued printing, and it is actually a lot better than picking out with a permanent marker. This was easy to do in Simplify 3D. You can actually cause a pause between sections. Now the other thing I did is I started having a look through Thingiverse, and I found a user, and I will put a link in it, had actually produced a single piece print. Now all of Gail's files, or nearly all, are designed to print on a small form factor printer, 120 by 120 millimeter bed. He's done that to try and allow the greatest number of people possible to be able to use his files. It does mean that there's a lot more assembly involved. So in this case it's a single print. Somebody had already combined those pieces together for a single part, and I think it actually looks better. Now I've got a 16 pixel ring, NeoPixel ring, and I hot glued that into place in the bottom. This just fits in. It's just a press fit. Now those NeoPixels look really cool when they are turned on. Do I turn them on? Yes. Unfortunately it does wash the camera out a little bit because it is so bright. I may yet have to adjust the maximum brightness, which you can do with the NeoPixel libraries. This is running from an Arduino Nano, which is plugged into a breakout board. Very handy for experimentation. Now up the top here I have a logic analyzer. It's a 16 channel logic analyzer, but I'm only using one channel today, and I've captured the signal pin going to the NeoPixels. NeoPixels are really cool because they have, each NeoPixel has 4 terminals, a ground, a VCC, usually 5 volt, a data in and a data out, and you can chain NeoPixels together, so you feed the data out of one to the data in of the next. And I'm not completely familiar with the protocol. There is methods of doing that, but let's have a look at what the signaling looks like. Okay, so when we look at the capture we can actually see lots of these spikes. But that's actually not really the whole of the story. If we zoom in to these spikes, we can actually see there's more to it than meets the eye. In fact, these spikes are very complex indeed. And it's these spikes are actually encoded with different timing signals between them to actually set colours. Let's see if I can get the start of it. So we're seeing timing cycles in the microsecond range, and these have to be very precise for it to work. We're actually using an 800 kilohertz frequency, which is a very high frequency. This is all handled for us inside the Adafruit NeoPixel library, which is very handy indeed. Okay, so let's look at the Arduino code that I've got running in that Nano. We're going to include the Adafruit NeoPixel headers. That's the library, because put simply they work and they work well. I'm defining a couple of variables here, or constants. NeoPixel is the pin that we're using, and number of pixels is how many pixels we're using within our NeoPixel ring. We then create an object, in this case called pixels, using the Adafruit NeoPixel library. We specify the number of pixels, what pin the pixels are on, and the style. There are a number of different styles. Not all of them are readily available, but Adafruit have made them all available. I've also defined some delay times, flash times, and fast flash times. In our void setup, we're actually just telling the new object to begin, and we're clearing it so that we end up with a blank NeoPixel ring. I've defined a variable called count, which I'm using to control the animations, as more specifically which animation is running at the time. And that's mostly because in the future, between each animation, I want to actually have the Arduino do another job. But that's not yet ready. And we're just going to sequence through all of the animations we have available. So we start at 1 and we run through to 23. There is actually one around 9 that's not used, and that's because I have an idea of separating the groups. So I can drop it into a different group, and when it's finished, it goes back to the first one. I then call NeoDisplay and which animation we're using next. NeoDisplay is very simple. It's just a switch statement, and we pass in which one we want to run, and it actually runs the animation. Now, color wipe is actually one that was created by Adafruit, and you specify the colors and the delay, and this is the one that makes it step around. And I just use a sequence of different colours for each one of those. Now, fade in and fade out are ones I wrote, and all they do is bring the pixel colour up from 0 up to whatever is setting the colour. So these can be combinations of, they don't have to be full brightness, because I'm using basically binary selection. I have 8 different colours that I'm playing with. If I chose to adjust these to say midpoints, 128, I could increase the number of colours, exponentially. Alright, this is actually the routine for fade in, and it's very simple. We run through counting X up to 200 each pass. Within that loop we set the pixel color and the brightness, and then once we've done that for all 16 pixels in our case, we then hit show and it sends that data out to the NeoPixels. We then delay it with wait, and that's passed in from here. So up here fade time was around about 10 milliseconds. Fade out is basically the same thing except we're counting down, and we're using X as our brightness control in both fade in and fade out. Color wipe is also a very simple one. It counts through all of the pixels we have, setting the pixel to the color that we specify, and then show, wait, and then repeat for the next pixel, which is how we get our color wipe. So it's all very straightforward. So I'll leave you with the animations, so you can see the different animations that I've been running, and I will see you in the next video. Don't forget to click subscribe and ring that notification bell so you know when my next videos come out.